Hi Hayden, so this is lesson 104. So we are going to follow the same steps every time we solve problems like these. And the first step is always to find the common denominator. And once we find the common denominator between all of the terms, then we're going to multiply each term by the common denominator. Okay? And then that's going to allow us to then simplify. And once we simplify, we can get to a point to where we can move all of the terms we're looking for. We're going to move all like terms together to one side or another, okay, depending on where they are. So we're going to move all like terms together, and then we will factor to find the term we want, or letter in this case, or variable, whatever word you want to use, and then we will divide by other factor, and that's going to give us the term that we want. So in this case, we have to find b. So our first step is to find a common denominator, and our two denominators are mb. So that is what our common denominator is. It's mb. So that's what we're going to multiply. That's our step 2, multiply by the common denominator. So I'm going to say mb times this, and mb times this, and this is going to be times mb also. So when I multiply mb times this, the m's cancel. So I get 3bz if I write the variables in alphabetical order. And when I multiply mb times n over b, b's cancel. So I get mn, writing them in alphabetical order. And when I multiply here, I don't have a denominator, so it's just straight multiplication. So I get bfm, writing it in alphabetical order. Now I'm looking for b, so what I need to do is get this b term with this b term. So I just simplified. Now I'm going to move all of my like terms together. So I'm going to move this over here. By subtracting it from this side, I have to subtract it from this side. So this cancels. So I have mn is equal to bfm minus 3bz. I'm going to take b, I'm going to factor b out of these terms, because this is the one I'm looking for. So I get mn is equal to b times fm minus 3z. All I did was I took the b out of both of these terms, and if I were to multiply b times this, I'd get this. B times this, I'd get this, right? So you can see how I just separated it out. I factored it out, and that was step 5. Now I'm going to divide by this factor to get b all by itself. So dividing by fm minus 3z on this side means I have to divide by that on this side. Because whatever you do to one side, you have to do to the other side. That means these two will cancel. So b is all by itself on this side. And the value of b is mn divided by fm minus 3z. This would be your answer. Okay? And let's just go and check it. mn over fm minus 3z. So b is equal to mn over, let's double check what we have, fm minus 3z. So fm minus 3z. Let's check that. And that's correct. All right, so you can see how we do it. We do it the same way every single time. We do these 6 steps. What's our common denominator? Multiply by the common denominator and simplify. Move all of the terms together that we're looking for, and then we factor to find the one we're looking for. Then we divide by the other factor to leave the one we're looking for by itself on one side. So let's do that again over here. This is find m. This is m, right? We're looking for m. So first step is find our common denominator. And our common denominator here is, we only have two denominators, so we multiply them against each other. So my. My is our common denominator. How cool is that? Spelled word. So my times this, my times this, my times that, and then my times this, every single term. Now we cancel out what is, if you multiply and divide by the same number, they cancel each other out, right? So we cancel them out. So we have 3am here. This doesn't have a denominator, so it's straight multiplication. So MSY, if we write it in alphabetical order, plus the m's cancel here because we multiply and divide by the same number, they cancel each other out. So KY here. And then this would be MXY if we write it in alphabetical order. So now what I'm looking for are the m terms. So I have a KY here, but I have an MXY here. I have an M and an M here. So common sense would tell me to get rid of the KY from both sides. And then to move this over, I'm going to subtract it. So minus MXY from both sides. All right, so this cancels, this cancels. So I have 3am minus MSY minus MXY is equal to negative KY. So now I'm going to factor the m out of each term. So I take the m out of the first term, I get 3a. M out of the second term, I get SY. M out of the third term, and I get negative XY is equal to negative KY. So m times this is equal to this. So I'm going to divide both sides by 3a minus SY minus XY. 3a minus SY minus XY. These multiply and divide by the same number, they cancel each other out. So m is equal to negative KY over 3a minus SY minus XY. All right, let's try that over here. So I have negative KY, is that what we said? 3a SY XY. All right, over 3a minus SY minus XY. And that is not right for some reason. Let me figure out why. It's probably a format thing. So let me look. All right, so what that was it was telling us, you see how this is negative? It was telling us to multiply everything by a negative 1 to change the value times 1 over 1. So I just added this for those who don't know to do that. This is a correct response. This is the valid response. But you could also multiply this by negative 1 over negative 1. Because this is the value of 1, you don't have to do it to both sides. Because it's the same thing as multiplying this times negative 1 over negative 1, which would be m. It would remain the same. But it would change the sign over here. You'd have negative m over negative 1, which would just make this positive m again. M is equal to, but this would change to ky over sy plus xy minus 3a. So it's the same thing, it's just the fact that Saxon doesn't like negatives. So I've added this answer as a possible answer because it is correct. So you can put it in just the way we solved it. Minus ky over 3a minus sy minus xy. That should help So now it should mark it right, and it is right. You don't have to reformat it. You can just take the natural fall. It's just that Saxon doesn't like to have a negative number in the denominator, so it changes it and multiplies everything times -1 over -1. But not everybody remembers to do that, so I'm going to put that in as a possible answer because that is correct. All right, so let's look at this one. Right here, and I'm going to actually erase this bit of stuff down here so we have a little bit more room. There we go. So now we have a blank screen to work with. All right, so we're going to find n. So our first step is to find the common denominator, which equals nx. And one of the things that you always want to do, especially when typing it into Jupyter, is just as you work the problem, make sure you put things into alphabetical order, because that's, if we all type it in alphabetical order, everybody will have the variables in the same order, so that you're more likely to get Jupyter to mark it correct. So we're going to multiply everything by nx. All right, so the n's cancel here, so we have ax. There are nothing to cancel here, so we just write it in alphabetical order, m, n, x. And then the x's cancel, so we have 5kn, and then we have nxy here. All right, looking for n, so we need to get the n's together. So I'm going to subtract ax from both sides. And I'm going to subtract nxy from this side so I can move it over here. So this cancels, this cancels. I'm going to write this with positive leading because that's the way Saxon likes it. So 5kn minus mnx minus nxy is equal to negative ax. All right. So we have a bunch of negative signs here. So in this instance, I am going to multiply. Well, no, you know what? I'm not going to. I'm going to leave it the way it is for now. We'll just solve it and see what our answer is, okay? So let's factor out the n. So that would be 5k minus mx minus xy is equal to negative ax. Divide by the other factor, 5k minus mx minus xy on both sides. N is equal to negative ax over 5k minus mx minus xy. All right, and I'm going to guess that maybe Saxon doesn't want the negative. I'm going to double check. All right, it will accept this answer just the way it is. All right, so let's do find D. Same thing. We've got to find the common denominator. In this case, D is part of the common denominator. So AD is our common denominator. So we'll multiply everything times AD. So the A's cancel here. So 2CD. And this would be ADX. D's would cancel here, so we'd have AB. So the D's are already on this side, so this one we don't have to move anything around. So we can say D times 2C minus AX is equal to AB. Divide both sides by 2C minus AX. This cancels. D is equal to AB over 2C minus AX, and that is correct also. We don't have to worry about any negative signs here, so it is going to be exactly what you see here. All right, in this next problem, we have to find the value of m. So we have another situation here. In this case, though, m is our common denominator. Our common denominator equals m. So if I multiply everything by m, then the m cancels. And m times 0 is 0, so it cancels that. So what I have is 1 plus m minus 3 is equal to 0. So I can just do some easy subtraction. 1 minus 3, and so that's m minus 2, because I combine positive 1 and negative 3. So if I add 2 to both sides, m is equal to 2. That's your answer. That one is easy. That one's actually pretty darn easy. But it uses the same principles as the other. You find the common denominator, and then you multiply everything. Then you combine like terms and simplify, and then you find the value of that one letter you're looking for. We didn't have to factor this time because we were able to solve using numbers. But that's okay. We're doing the same thing in the other problems. It's just that we can't get numbers. We have to get a relationship of letters, of variables. So this one was actually pretty easy. So let's look at this graphing problem here. So we have negative absolute value of x minus 2 is less than a negative 4. So let's look at each one. First of all, we got to get x by itself. So we're going to add 2 to both sides. Now we want to get rid of this negative sign. So we multiply everything by negative 1. So that gives me the absolute value of x. It takes the opposite of this, so we flip the sign, and the opposite of this, which would be positive 2. Now, this is what we're graphing, right? This is the actual term. So we have to allow for this to be positive and negative. So positive would be x is greater than 2, and negative would be negative x is greater than 2. Well, again, we don't want a negative x, so we multiply everything by negative 1, which means we have x is greater than 2, and then we have x, the opposite of negative x is x, the opposite of greater than is less than, and the opposite of positive 2 is negative 2. So we have these two scenarios that we are graphing, right? So if x is greater than 2, but it's less than negative 2, then we have a disjunction. So it is, you circle the 2 and you go this way, and then that's x is greater than 2, and x is less than a negative 2 would be circling the negative 2 and going this way. And that's how you would graph that. All right, not super hard. You just have to allow, when you have an absolute value, you have to allow for the fact that x could be positive or x could be negative. And when it's negative, we have to change it back to a positive, and that flips everything. All right, so now we're going to add these two. So in order to add them, we have to have a common denominator again, right? So the way to get the common denominator is to factor. So 4 over, this is a perfect square, so we know that's going to be x plus 2, x minus 2, plus 3x over x minus 2. So to get a common denominator, we have to take all of the elements under all of the terms. So that means our common denominator is x plus 2 times x minus 2. So we have to multiply everything by that common denominator, right? Our common denominator is x plus 2, x minus 2. So if I multiply everything by x plus 2, x minus 2, right? X plus 2, x minus 2, what I get is that these cancel. So what I have here is the same thing. I have 4 over x plus 2, x minus 2. And we can't cancel anything out because we don't have an equal sign. We don't have an equation. All we can do is if we have a denominator, we can take it out of the numerator. We are not going to multiply by what we already have. We're going to multiply by what we don't have. So this one would go away. So we would multiply this by the top and the bottom by this. So that would be plus 3x over x plus 2, x minus 2. Because this is the one that has to be multiplied by the top and the bottom. The other way that, let me do it in a way that probably makes more sense. I'm doing a lot of this in my head, so I'm going to do it the long way for you. This is the long way. Let me erase all this. I don't want to confuse you. When you do it with an equal sign, it's different than when you do it without an equation. If it's just an expression, which this is an expression, there's no equal sign, it's a little bit different. So you have to multiply the top and the bottom by both. So what we're actually doing, what we're technically doing, is we are saying x plus 2, x minus 2 over x plus 2, x minus 2 times 4 over x plus 2, x minus 2, right? That's what we're technically doing. And because we already have this here, it cancels. We can cancel this one and we can cancel this one. But we still end up with 4 over x plus 2, x minus 2, because we have 1 here and 1 here. 1 times 4, and this times 1. This remains this same fraction. So when we do the same thing to this fraction, we say 3x over x minus 2 times x plus 2 over x, or times x minus x plus x minus. The only thing that cancels is the x minus. So what we get is plus 3x times x plus 2 over, because this becomes 1, x plus 2, x minus 2, which is the same thing that we were doing before, except I was doing this bit in my head. And I want you to see exactly what's going on, what's canceling and how it's canceling. We're multiplying the entire common denominator as 1, as the value of 1, because we can multiply something that has a value of 1 times a fraction without changing, or times any number without changing its value. So by doing it as a fraction of the common denominator over the common denominator, we're actually multiplying it times 1, because regardless of what it is, when you have the same value over the same value, it equals 1. So you can multiply any term by 1 and the term remains the same. So that's what we're doing with the common denominator. We're turning it into a fraction that equals 1 and multiplying it times both of these terms. When we do that, we are allowed to cancel out whenever we multiply and divide by the same factor, because we know that that is just a way to reduce ahead of time, and what we're actually doing is we're dividing by 1, which doesn't change the value of the term. It stays the same. So now, because of what we're doing here, I'm going to multiply this. Because we want to have a common denominator. Now, could I cancel this? Yes, I could cancel that, but then we would be back to where we were. We don't want to be back to where we were. We want to be able to combine these. So if I've got to say 4 plus 3x times x would be 3x squared, and 3x times 2 would be plus 6x. All of that over x plus 2, x minus 2. Now we have it in one term. I'm going to factor this and see if there's anything in common that we can now factor out, now that we've added everything together. But in order to do that, I've got to put this in descending order of the variable. So 3x squared plus 6x plus 4 over x plus 2, x minus 2. So let's see if we can factor any of this. So we've got 3x squared plus 6x plus 4. I don't think there's a way that we can factor it. So I think that it just remains the same. So let me check and see if it remains the same. (3x squared plus 6x plus 4). Okay. 3x squared plus 6x plus 4 over x plus 2, x minus 2. Let's see if it takes that. Yes, it does. So that means we couldn't factor this and cancel anything out. So that would be your final answer. All right, just like that. All right, so let's look at the next one. This, I feel like you should be able to do. All you need to do is put it in your calculator. So if you pull up your calculator and you put 26 square root of, you want to go to the nearest hundredth, which would be this place. So this is a 9, so it would round. So it'd be 5.10. You want to round this to the nearest millionth. So again, on your calculator, that's all you're doing. You're going to click pi. And the millionth would be, let's see, this is 10th, 100th, 1000th, 10,000, 100,000, millionth. So this would be rounded to a 3. So 141,593. All right, now this we want to round to the nearest 10. So that would be this position right here. So the 7 would round that to a 5. So 5250 would be the number there. And those are all correct. Which of the following most resembles the below shape? All right, so this S, this is a cubic graph. So it's going to be either this one or this one. This would be a parabola, and this would be a curved ray. So it's not these two, it's either this one or this one. We have to know whether this is opening up normally, which would be the positive, or upside down, which would be the negative. And actually upside down would be with this side up and this side down. So this is the normal one, so it's this one. And that's correct. So now let's do this problem. We're going to find the area of the green shaded portion of this parallelogram. Dimensions are in inches. So in order to find the area of a parallelogram, it's exactly the same as a rectangle, length times width. So the area is going to equal length times height, the two dimensions that we use to designate the size of the parallelogram. So in this case, the height is 6 and the width is 9. So we're going to say 9 inches times 6 inches, and that's going to equal 54 inches square. So that's the area of the whole parallelogram, but now we've got to subtract the circle. So the area of a circle is equal to pi r squared. So that's going to be pi times 2 inches, because this is a 2, times 2 inches, which is going to equal 4 times pi inches squared. So we're going to subtract this from this, but remember you've got that 4 pi, so these are not like terms. So we cannot subtract them, we can only represent that subtraction. So that's going to be 54 minus 4 pi in inches squared. That is your answer. That's all you can do. So we go over here and we type that in. We're going to type in 54 minus 4 pi parenthesis, actually let me put the parenthesis in front, space in period exponent of 2 because it's area. Check that and it's correct. And that is all we had in lesson 104. So I hope this helps. If you have any more questions, please ask.